superpower number 2. So switching from a state-based to an event-based data model can help bring a lot of new meaning to your data. And as mentioned before, an event-based data model is like using vectors rather than scalars in algebra. So the more changes there are, and the more dimensions there are in your space, the more useful it seems. So for example, while our tracking example here, it's kind of simplistic, let's imagine giving directions, to say a hiking trip. So for a trip like this, right, would you rather you receive directions in discrete points on the map, in longitude, latitude, something like this, right? Or maybe something richer like this, right? It's obvious that you notice that instructions for hikes naturally have a lot of descriptive directions because you really don't want to fall off a cliff. And so these kinds of context-rich directions are more like events rather than states. And events seems to be more useful as uncertainty increases inside your environments. The reason for this is because, say, single events are typically easier to understand than complex objects. So let's say a lot of APIs, webhooks may give you entire full object graph of what you're subscribed to. But sometimes this has dozens and maybe even hundreds of fields. It really sucks, those things. But sometimes it's just easier to just publish an event, so say a sales discount applied. This is much more readable than hundreds of fields. Events also help clarify multiple meanings to the same kind of update. So sometimes two separate updates with the same value has totally different meaning. So for example, in a hospital system, when I say a discharge date was updated, was the patient really discharged or was he transferred to a hospital? For an online retailer, when the last name was changed, was it a fix or a typo, or the customer maybe was married recently, right? The action we want to take can be drastically different depending on the meaning behind it. I call these intent confused updates because the intention behind this is often not clear. So it's useful to understand how system transitions across time. While it's relatively easy to transform series of states to events for some systems, others are kind of hard or even near possible to do. So for example, it might be foreseeably easy to translate a state from something like this to this, right? But it's far more harder to translate, say this to these kinds of directions. So I call this a state to event translation problem. And sometimes it's just easier to capture the original event instead of trying to guess what happened between the states and try to find a delta for that. So there are a few good benefits that come out of this. And as mentioned before, events are aligned, can help align the use of the same language between business and developers. And events represent a user or business intent. And so naming it this way, brings greater alignment between devs and businesses. So sometimes devs may not fully understand terminologies used by devs, and that's very natural. So for example, developers may think that onboarding in an HR system means, okay, let's just add all the employees into the IT system. But to business, onboarding also need to make sure employees are settled down. It includes face-to-face catch-up 1 month, 3 months into the job. So sharing the same language helps developer understand the business. Using events as your data model is also a great fit with like event-based modeling techniques like event storming, event modeling. And these techniques can help developers understand complex processes and discover areas of improvements. It can also be used in like greenfield projects to understand new use cases. And in event-based state transition databases, like events are stored at, this also fits very well with event-driven architecture. So where like events in event store can be published to, like, say, message buses or brokers to communicate with external systems. And since events are stored in sequence and they're also immutable in event store, it's very easy for external systems to replay the events and to ensure the same events are always played back. And this is a lot more stable compared to state-based databases where data tends to be a lot more volatile and the history is not often available. Events, again, are usually smaller and more fine-grained, and so doesn't take much bandwidth or storage to store compared to like historical records of complete states. And there are distributed business processes across systems that can be easier to track, like by tracing events that are stored in each system. So lastly, event-based models also give a lot more insight for data analysts because it captures also the intention of a data change, which is another extra dimension for them to work with. So say when an account balance is increased by 10,000, it is more useful to see whether it's increased because there was a deposited event or whether it's like a transferred event from like a suspicious account.